Hello, welcome to my presentation on chemistry that changed the world. Today I'm going to talk about thin layer chromatography, what it is, its applications, and its feature. To start with, I'm going to talk about how it works. So, to begin with, there's the mobile and stationary phase. In TLC, the stationary phase is a layer of silica that is finely packed onto a sheet of aluminium. The silica particles each have to be the same size, or else the surface area would be different, causing the eluent to move up the stationary phase at different rates. This is also affected if there is any damage on the plate. The mobile phase is determined by the substances that are having to be separated, which I'll talk about later. Next is the method. So, for TLC, a beaker is filled with a small layer of the chosen eluent. On the TLC plate, a line is drawn in pencil slightly above the base, above where the eluent will cover. Then, using a capillary tube, some of the mixture that is being separated is put on the line. Alongside this, known compounds can be placed in order to compare how far different compounds move up a TLC plate. The TLC plate is then put in the beaker with a watch glass over the top so that the atmosphere is saturated in eluent. Filter paper could also aid in this. The eluent will move up the TLC plate and, depending on the different compounds' adsorption to the stationary phase, this determines how far up the plate they move with the mobile phase. Before the eluent reaches the end of the TLC plate, it should be removed from the beaker, and a line should be drawn in pencil where it ended. The compounds can either be seen by eye or under UV light depending on if it's a coloured compound or UV active. The eluent is determined by the compounds that are being separated. A suitable eluent will be able to move the components up the TLC plate, but not at the same rate. This is usually determined by polarity. If a component is polar, it will adsorb better to the polar phase. In TLC, the stationary phase is more polar. If the components needing to be separated are nonpolar, the mobile phase will have to be nonpolar so the compounds are moved up the TLC plate. The least polar compound in this case will be moved further up the plate. In TLC, certain calculations can be done in order to help identify the component. For this, the RF values are calculated and compared to a database of values, but this depends on the eluent that is used, as this will change the values. They're calculated by determining the distance from where the mixture was dotted to the centre of the compound, seen either by eye or under UV light. This is divided by the distance to the solvent front, which is where the mobile phase was stopped. TLC has been used in many areas of science, such as in cosmetics. TLC is used to separate colours and preservatives, which can then be identified using their RF values. In medicine, thin layer chromatography was used to discover what plant extracts were used in traditional medicines and help determine the differences in metabolites of plant species in relation to where they're found. In food, TLC quickly and easily identifies dyes that are present. TLC can be used to identify drugs during forensic analysis, either from within blood or from an unknown sample, which could help with a criminal case. TLC can also be used in biochemical analysis to test for antioxidants and for isolating metabolites. TLC can be used to test if a sample is pure, as it should only produce one spot when separated if pure. Thin layer chromatography was used to determine how pesticides moved through soil by comparing the RF values of thin layers of soil. Finally, in pharmaceuticals, TLC is carried out to detect impurities. All of these are vital in everyday life, so TLC has had a massive impact on us in my opinion. Recently, digitally enhanced TLC has been developed, and advances are continuously being made. This method is easy and cheap to use, as a fluorescent TLC plate is lit using UV light, and a camera is used to take a picture of the results. This method is very accurate and can easily be converted into different outputs, such as calibration curves. It can be used to determine the number of components in a mixture and to monitor a reaction's progress. This also works well for substances that are harmful to touch, as results can be taken from a distance. The method itself has no associated risks. All the risks come from what is being tested. Thank you very much for listening to my presentation on thin layer chromatography and how I think it has changed the world and how this is still changing.